Well, good morning. Welcome to Tesla Northwest and EVs. I'm so glad you could join me. You and I are going to take a journey through all the different types of Tesla charging. We're going to learn the terms, we're going to learn a little bit of the technical jargon, and overall, when you get done with this video, you should know everything there is to know about what it means when you hear somebody refer to a Tesla city charger, or maybe they talk about a version 3 supercharger, or maybe the mobile charger, also known as the EVSE. So stick with me. I'm going to cover a little bit of the basics about electrical, and then we're going to see each of those different chargers in turn. So thanks, and join me on the flip side here at Tesla Northwest and EVs. Okay, the first thing we should do is talk about the types of EV charging out there. This applies to both Tesla and your CCS1 cars. So this is just a good quick lesson. You're going to hear what's called level 1 charging. This is alternating current. And what is alternating current? Again, it's an analog signal, up and down continuous. It's like what's in your household outlet. And a level 1 charger is typically 120 volts. It's pretty slow at about 4 miles an hour. So it's not going to charge your car real fast. And you're typically going to look at power at about 1.4 kilowatts. And we'll talk more about that in a moment. The next type, again, is another AC charger or alternating current, so household power. And these are what's known as a level 2. And those are typically going to be 208 or 240 volts. You'll also find these are going to be typically Tesla destination chargers or your Tesla mobile charger. Same with the level 1, can be a mobile charger or a Tesla destination charger. And we'll talk again about the differences. And then finally, you get about 25 miles an hour with level 2 AC charging, so it's much faster. And power ranges are somewhere in the 6.2 to 11.5 kilowatt range, although those can vary. And then finally, we're going to have what's known as DC fast charging. These are the Tesla Superchargers, and these can be upwards of 250 kilowatts at a version 3, and we'll talk about version 4 and how they're going to be even faster. So again, these are the terms you're going to hear. Level 1, typically 120 volt AC. Level 2, typically 208, 240 AC, alternating current. And then finally, DC fast charging, which is going to be like the Superchargers, EVgo, Electrify America type places. All right, so let's just talk quickly about what kilowatts are, and then we'll jump into talking about chargers. All right, folks, let's talk about a couple electrical fundamentals just so you understand the jargon as all these beautiful birds chirp here in the background. So a couple things we want to understand. Number one, our power sources. So first off, you're going to hear the term AC. That's alternating current. It's like what's in your household outlet. The other term you're going to hear is DC. That is direct current. It's like what comes out of a battery. Alternating current has these ups and downs known as a sine wave. It's analog. And DC current just moves in one direction. It goes from positive to minus. So we have AC charging, DC fast charging. And then some quick terms. One of the electrical terms you hear is resistance. This is the electrical friction. It's what's kind of keeping the electrons from flowing, and it's symbolized by the ohm. Then you're going to hear the term volts. Volts is represented by an E for electromotive force, and that's what's the electrical pressure. It's what's giving it the oomph to move down the line. And then you have amps. And amps is represented oftentimes by an I for intensity. And this is your electrical flow. This is the electrons actually moving down the conductor. So you've got resistance, electrical friction. Think of the walls of a pipe slowing down water. You've got volts, electrical pressure. So think of water pressure in that pipeline. And then finally you have amps, which is the flow of that water down a pipeline, but in this case electrons. And what do you get if you combine pressure and flow? Well, in this instance, we get power. We get what's known as wattage. And wattage is a simple formula. It's volts times amps. It's known as Joule's law. And so if you took 240 volts times 48 amps, which is a typical Tesla destination charger, that gives you 11,500 watts or 11.5 kilowatts. So kilo just means 1,000. So those are some general terms that you want to be familiar with. If you have more questions, please put them in the comments. I'd be happy to answer them. This is what I teach up in Bellingham. So thank you. All right, let's jump into it and see what the different chargers look like. All right, folks, the first thing that we're going to have is what's known as the Tesla mobile charger. This is also called an EVSE, electric vehicle servicing equipment. It's not actually a charger. It's the piece of equipment that takes your household AC power and helps step it down, convert it, and do smart stuff so it can charge the battery. So if we open this guy up, we get this adapter comes with it. It is the household 110 volt adapter. And then if you want to get bigger adapters so you can charge faster at level 2 speeds, you can get something like this. This is a 50 amp adapter. And so is this is another, I believe this is a 50 amp as well for a dryer outlet. So 2 good adapters to have. The Tesla mobile charger itself no longer comes free with the vehicles. It is now $200. It's rated at 32 amps maximum. Let's see if we can squeeze in on that. Yeah, a little hard. 32 amp rating maximum, and I will give you the max kilowatt output in the notes. So again, first one we're looking at, this is what's known as the Tesla mobile charger. $200 on their website. It doesn't come free anymore, but I highly recommend you get one. And I highly suggest you get some adapters so you can charge at faster speeds using a dryer outlet or a 50 amp welding outlet or going to a campground. All right, we're going to skip to our next one, and number 2 is going to be a destination charger. All right, hey, welcome back. So this is number 2 on our list. We started with the Tesla mobile charger, number 1 EVSE. That does level 1 up to level 2 AC charging. So you can go household all the way up to 36 amps with the Tesla EVSE, the first one we looked at. This one is the second option you may want to consider. This is what's known as a Tesla destination charger or a Tesla destination EVSE, again, electrical vehicle servicing equipment. You can find these at hotels, resorts, different places where you're going to be spending a fair amount of time, and then obviously also at your home. These are a great bargain. I highly suggest that you take a look, and if you're thinking about it, get one installed. They will do up to 48 amps, and you can output 11.5 kilowatts. Again, where did I get that number from? 240 volts is what it's wired to in my panel. I've got it hooked to a 60 amp breaker. You got a D-rate because this is a continuous load, so that's where the 48 amps comes from. 40 times 48, 11,500 watts. So this charges my car in about 3 to 5 hours, depending on state of charge, and obviously I can schedule the charging. Really great option. All of them have the Tesla end on them. This has a 20-foot cord, or 22-foot cord, so plenty of reach, and very easy installation. If you want to check out my video on that, I've got a couple on how to install the Tesla destination chargers. So with that, we're going to move on now, and we're going to talk about DC fast charging. So we're going to head over, we're going to look at a Tesla City Charger, then a version 2 Supercharger, and then a version 3 Supercharger. So thanks again, folks, and I'll catch you in a little bit. All right, hey folks, welcome to Tesla Northwest and EVs. So where are we at? We're at the Burlington, Washington Supercharger. This is a version 2 Supercharger, but the great thing about it is it's got city chargers and version 2 city Superchargers, so we can see both. And what is this exactly? It's DC fast charging, as opposed to the level 1 and level 2 charging we talked about earlier. So your battery can charge faster because we're going directly DC to DC, direct current to direct current, as opposed to the onboard charger on your car having to convert the alternating current out of your house into direct current to charge the battery. So that's why we can go so much faster at a supercharger, and let's see what the differences are between them. So I'll catch you on the flip side and we'll go and see what they are. All right, and what we can see here first off are what are known as city chargers. These are slightly shorter. They are about 82 kilowatt, and let's get in and look at the tag here real quick. 82 kilowatt, and this supercharger happens to have these as overflow because it is a very busy spot. We can see the cabinet for the city chargers, and let's take a look at its tag as well. And again, these are about 200 amps at 410 volts DC, and you can hear the fan running, and that is what is known as a rectifier. So it's taking AC power and transferring it into DC, and then your car gobbles those up. So let's move on and talk about the version 2s next. All right, folks, and this is what's known as a version 2 supercharger. This one in Burlington is an 8-stall supercharger. And what's the difference between a city charger and a version 2? Well, first off, you can see it's much taller. It's also more powerful. Again, this city charger is about 82 kilowatt output. and a version 2 supercharger is 150 kilowatts of output. But there's a couple things you want to know about these. Number one, there is a power sharing going on. So these are lettered. You can see this is 4B, the one next to it is 3B, and then you'd have a 4A and a 3A, etc., etc. And so what happens is when you pull up, you want to leave one stall available if you can, because if you plug in to 4A and somebody's already plugged into 4B, you're going to get less power. You're going to share that 150 kilowatts between the A and the B. So you're always better off to skip a spot if you can, but if you can't, plug in, and as soon as the person leaves, your output should go up. So again, this is a version 2 Tesla Supercharger. This is an 8 stall. And one other way you can tell the difference between a version 2 and a version 3 is the cables are longer, and again, the numbering scheme. So you have 1A, 1B, 2A, 2B. And then the city chargers, again, smaller, 82 kilowatt output. So we'll be heading off. We'll go and check out a version 3 and give you all the details on that. Catch you on the flip side. Okay folks, so the next DC supercharger we're going to talk about is what's known as a Tesla version 3 supercharger. So I'm going to take you to Everett. I'm going to let you see what that supercharger looks like, kind of what the amenities are around it, and just give you a general sense of what a V3 supercharger site looks like. What are some of the stats about a version 3 supercharger? Well, it is 250 kilowatts for number one, so it is much faster than a version 2 by 100 kilowatts. Number two, you don't have to power share at a version 3 supercharger, at least not very often. All of the cabinets that I showed you, like that equipment from the V2, they have a DC bus that connects them, which allows almost every single time you go to charge, you get that full juice, at least at the beginning, right? Depending on your state of charge, you're going to charge faster or slower. But a version 3 is capable of 250 kilowatts. You don't have to power share like you do on a version 2 with the 4A, 4B style of numbering. It's just 1 through 8, 1 through 12, however many stalls there are. And the cables are also much, much thinner on a version 3 supercharger. I will show you a picture of that. So overall, version 3 superchargers are a great option if you've got a newer Tesla, anything like 2019 and newer. Some of the older Model S's may want to go to a version 2 because they really don't benefit from having that faster charge speed at a version 3. But you will find them, again, intermixed. They're being added all the time, and it is a great, great option, especially if you want some of those faster charging speeds. So thanks again, and I'll catch you on the flip side as I show you a version 3. So I am at a brand new version 3 Tesla Supercharger in Everett, Washington. It's 1 mile off of Interstate 5. Great location. It's a 12-stall supercharger with a handicap pull-through, and it also has 2 level 2 AC chargers for free. First 2 hours are free, and then it's $2 an hour after that. Really good location, beautiful spot. No magic docks, unfortunately, but there are plenty of things to do. A Target, Sportsman's Warehouse, and then you've got your Starbucks and a Chipotle plus some other Vietnamese food and whatnot. So overall, great location to charge, and hopefully will be opened up to all EVs soon. Again, new V3 Supercharger, 12 stall in Everett, Washington. Everything was working great. All right, and then our last Tesla supercharger that we want to talk about are what are going to be called version 4 superchargers. Now, they haven't made it to the United States yet. They're only in Europe, and so far I've only heard of one station being open, and I will show you some pictures of that. But version 4 superchargers, what are those all about? Well, they're going to have longer cables. So I believe they're about a 3-meter long cable, or about 10 feet. That way they can accommodate all the different EVs from manufacturers, because they put the charge port in weird spots all over the place. So number one, they'll have a longer cable. The cabinets are going to be a little bit taller to accommodate that cable. And then finally, they're going to be capable of 1,000 volts. At least they are in Europe, and they should hopefully be capable of that in the United States. And what does that mean? Well, some of your higher voltage cars, like your Porsche Taycan, your Honda Ioniq, your Kia EV6, those all use an 800 volt architecture, and so they need a higher voltage. So we're hoping that the version 4 superchargers will be 1,000 volt, 600 amp, so that's about 600 kilowatts. So we'll see what happens when they make it to the States, and as soon as I can find one, I will bring it to you. So version 4 superchargers, again, they're going to be the next iteration. haven't made it to the United States yet. They're in Europe, but we should hopefully be seeing them in the coming months and years, and it should be a great, great thing, especially with the Cybertruck coming. And we're a reservation holder, so again, hit that subscribe if you want to follow more of this great content. So thank you very much, folks. This has been a fun video. Let's do a quick rundown. So what did we talk about? We talked about number one, your Tesla mobile charger, or your EVSE. That's going to be your slowest way of charging, and it's about an 8.5 kilowatt max output. Then we talked about level 2 AC fast charging, AC charging, which is going to be your Tesla destination charger. And again, that's going to be about an 11.5 kilowatt output. Both of these are great options for at home, at resorts or hotels, different places where you might be parked. The Tesla mobile charger is a great option to buy when you first get your Tesla. It's only a couple $100s. You can use it at your home. You can plug it into your dryer outlet. Heck, you can even plug it into a wall outlet if you have to. But at least it gets you started. And then you can upgrade to the Tesla destination charger. Hang that on your wall, get one installed. You may have to do some electrical work, and I've got a video showing you how to do that installation. And those are your two AC chargings from Tesla. Again, your mobile charger and your destination charger. And then we talked about the different types of Tesla DC fast charging. I showed you a city charger, which those are shorter, squattier, and they're about, well, max 82 kilowatts or so, but really it's probably about 75 kilowatts you're going to see coming out of those. And then we showed you what's known as the Tesla version 2 superchargers. Those are 150 kilowatt superchargers. They use a power sharing policy between them. So if you have a 12 stall charger, you're going to have 1A, 1B, 2A, 2B, all the way up to 6A, 6B. And so if you pull into 6A and no one's there, you're going to get all 150 kilowatts. But if you pull in and somebody's at 6A and you take 6B, you're going to get whatever's left over that they're not using to charge their car. So good etiquette at a version 2 supercharger is to skip a stall if you can. If you can't, that's okay. But remember, you're power sharing, so you want to get as much juice as you can. So if you show up and plug in next to somebody, you're just getting their leftovers. So good etiquette is move over if you can. And it's a good idea to watch how fast you're charging, because sometimes in a version 2, somebody may leave, you're parked next to somebody else, and you can move your car over, and now you can get faster speeds. And then finally, we ended with the brand new version 3 Supercharger in Everett. I took you for a walk around that, and it's a great option, especially for the newer cars, because it charges up to 250 kilowatt max, and the power sharing is not as big of a deal. Yes, if it's a fully loaded version 3 Supercharger, every stall's taken up and every car is dead, you're not going to get your full 250, but for the most part, because they do have a bus connecting the cabinets, you get almost full power every time you go. And there's no 1A, 1B, etc. It's just 1, 2, 3 through whatever number of stalls there are. And then finally, folks, we talked about the exciting new version 4 Superchargers coming. We don't have them in the United States yet, but they should really open up the supercharging network for non-Tesla EVs with a longer cable, a 1,000-volt architecture, and we're really hoping a 600 amp maximum to give us that 600 kilowatts. So thank you again for joining me here at Tesla Northwest and EVs. I hope you found this interesting. I'd love it if you'd leave me a comment. Let me know what you'd like to see next in the video. And hopefully, if you really want to nerd out, let me know. I can get in some more depth on this electrical stuff. But you can also go check out Brandon Flash or Out of Spec Studios for some great information on charging as well. Tom Malogny at State of Charge is great also. So hey, thanks again. Have a wonderful day, and I'll just catch you on the flip side here at Tesla Northwest and EVs.